Dear students, good morning, namaste. This is the 11th part. Already we completed the 10 parts. In the previous 10th part, we discussed some problems 14, 15, 16, 17. In the exercise 11.2 about the concept finding the shortest distance. Okay, now? Those problems are important. One example 14, 15, 16, 17. Finding the shortest distance between two skew lines. If the lines are given in the vector equation or otherwise in the Cartesian form also. We completed those concepts. Okay, now we are going to solve the remaining problems that 1 to 13 are there. Observe it. For my sake, I wrote on the board. You open the textbook and you see there only. The exercise 11.2, the first problem is, show that the lines with DC's direction cosines are given are mutually perpendicular. Very good concept. We have to show the lines, but line equations are not given. The line means, no doubt, it is containing DRs or otherwise DCs. We are given DCs. You see, observe it. First one, given the DCs of the set of three lines are 12 by 13 minus 3 by 13 minus 4 by 13. 4 by 13, 12 by 13, again 3 by 13. 3 by 13 minus 4 by 13, 12 by 13. Okay, now? There are three lines which are having the DCs L1, M1, N1, L2, M2, N2, L3, M3, N3. You see, it is L1, M1, N1, L2, M2, N2, L3, M3, N3. We have to show that they are perpendicular. You see, L1, L2 plus M1, M2 plus N1, N2. They are the DCs, not DRs. What about, we will see. L1, L2 plus M1, M2 plus N1, N2. This is 12 by 13 into 4 by 13. This one, L1, L2. Plus minus 3 by 13 into 12 by 13 plus minus 4 by 13 into 3 by 13. Okay, now? Right. You see, 12 fours 48, not 124. 12 fours 48 minus 3 into 12 minus 36. Here also minus is there, minus 12. But 13 and 13, 169. It is 0. 48 minus 48. Okay, now? If L1, L2 plus M1, M2 plus N1, N2. Okay, now? The sum of product of the DCs of two sets of lines. I am taking only two sets. If it is 0, then L1 is perpendicular to L2. Of course. This is about L1, this is about L2, it is about L3 line. You assume like that only. L1 is equal to 0 is a line, first line. Whose DCs are this one? L2 is the second line, whose DCs? Right. So here with this formula, it is equal to 0. So L1 is perpendicular to L2. Next, we will verify L2, L3 plus M2, M3 plus N2, N3. Okay, na? That is equal to It is 4 by 13 into 3 by 13 plus 12 by 13 into minus 4 by 13 plus 3 by 13 into, that is 12 by 13. You see, here 4 3s 12. 12 fours minus 48 plus 3 12s 36 by 13 into 13 169. Here also it is 0. 12 plus 36 is 48 minus 48. It is 0 by anything is 0. So here also L2 is perpendicular to L3. You will agree that? Okay na? Similarly, we can solve L3 L1 plus M3 M1 plus N3 N1. That is 3 by 13, 12 by 13. Minus 4 by 13, minus 3 by 13. 12 by 13 into minus 4 by 13. This is minus is there. Minus 4 by 13 is there. So here also 12 3 is 36. Minus into minus plus 12. That is 12 into minus 4 is minus 48 by 13 to 13 169. Here also it is 0. That implies L3 is perpendicular to L1. So first one is L1 is perpendicular to L2 and that L2 is perpendicular to L3 and this L3 is perpendicular to L1. So they are mutually perpendicular. Okay, Naina? Therefore, we can conclude that the lines are mutually perpendicular. And given lines, we have to write given lines are mutually perpendicular. Okay, na? Like that we can solve. Here the main concept is L1 L2 plus M1 M2 plus N1 N2. That is to be 0. That sum of product of DCs of two lines. If it is 0, then they are mutually perpendicular. Now the second one. Show that the line passing through the points is perpendicular to the line passing through the points. You see in your textbook, it is clearly it is given. You see, given points, A, we assume 1 minus 1 2. B 3 4 minus 2 and C another set is 0 3 2 D 3 5 6. There are two pairs of lines, pairs of points are there. First A and B given, next C and D given. Through A and B a line is passing, say L1. Through C and D, another line is passing. Say it is L2. And here we have to show that they are perpendicular. Now you see, line passing through A and B having DRs. I am writing here DRs, not DCs. DRs having the DRs of the line which is passing through A and B are 1 minus 3, minus 1 minus 4, 2 minus half minus 2. Please observe it. x2 minus x1 or x1 minus x2. The difference of coordinates. 1 minus 3, minus 1 minus 4, 2 minus half minus 2. This is minus 2, minus 5, 4. Or otherwise, it is 2, 5, minus 4 also. I am taking the minus as a plus as a minus. These two minuses plus 4 is a minus 1. Like that also. Similarly, any line that is passing through C and D, having the DRs. Another line which is passing through C and D. Then that line is containing having the DRs. You see that 0 minus 3 or 3 minus 0 also. 3 minus 0, 5 minus 3, 6 minus 2. Like that. Okay now. You see, this is 3 minus 0 is 3. 5 minus 3 is 2. And 6 minus 2 is 4. Any confusion? If any line having the DRs which is passing through 2 points means x2 minus x1, y2 minus y1, z2 minus z1. Or otherwise x1 minus x2 also, y1 minus y2, but taking only one order only. So like that I found the DRs of 2 lines which are passing through A and B, another one is passing through C and D. So these are the set of, you see, it is a set of DRs of 2 lines. Now, next, say this is hence we assume it is L1, M1, L1. It is nothing but 2, 5, minus 4. L2, M2, N2. It is nothing but 3, 2 and 4. Okay, Dada? We assume like that. Here also, L1, M1, L1, L2, M2, L2, we may write it as. Now consider, we'll see. L1, L2 plus M1, M2 plus N1, N2. It is 2 into 3. Okay, now? It is 5 into 2 plus minus 4 into 4. Will agree? 2 into 3, 5 into 2, minus 4 into 4. This is 6 plus 10 minus 16 is equal to 0. That implies if this formula is satisfied, that is L1, L2, M1, M2 plus L1, M2 is equal to 0, then the line AB is perpendicular to CD. Okay, na? Okay, na? You write it as also AB bar, CD bar. That means line only. The line AB is perpendicular to line CD. That is the second one. Now, I am going to solve the third one. Show that the lines same. The set of 2 points are given is parallel to another line which is passing through the set of another 2 points. Second one is perpendicular. Third one is parallel. We have to show that they are parallel. Observe. Set of points A. What is A? It is 4, 7, 8. B. 2, 3, 4. C. Minus 1, minus 2, 1. D. The 1, 2 and 5. Okay, now? Still. The arcs directly. The arcs of line AB. Simply, we may write it as AB. or otherwise the line passing through A and B having the drs. Not needed to write like that. The drs of line AB that is passing through A and B is actually formalized x2 minus x1, y2 minus y1, z2 minus z2. That means 2 minus 4, 3 minus 7, 4 minus 6, minus 2, minus 4, minus 4. Okay, na? Minus 2, minus 4, minus 4. Dividing with minus 2, it is 1 comma 2 comma 2. What is it? First you delete the minus and 2 twos, 2 twos, 2 twos, 2 1, 2 twos, 2 twos. So they are drs. Similarly, drs of CD. CD also 1 minus of minus 1, 2 minus of minus 2, 5 minus 1. This is 2, 4 and 4. It is also 1, 1, 1, 2, 2. Here, say it is L1, M1, L1. It is also L1, L2, M2, L2. The ratio must be same. The ratio must be same. That is the formula. Okay, now you see that, observe. You see L1 is 1 by 1, 2 by 2, is also 2 by 2. The ratio is same, 1, 1, 1. Hence, AB parallel to C. Okay, now? Like that, we may prove. Next, the fourth one. Find the line passing through the point and parallel to the vector. Say, given point is capital A is 1 comma 2 comma 3. A line is passing through a point and line is required line. Required line is parallel to vector B bar is equal to, that is 3i plus 2j minus 2j plus 2j minus 2k. Okay, na? 3, 2 minus 2 is there. Point is 1 to 2. That means point means whose position vector is A bar. It is A bar then. A bar. A bar means I plus 2j plus 3k. Many times we discuss. Required vector equation of line is R bar is equal to A bar plus lambda B bar. What is R bar? A bar I plus 2j plus 3k. We are given only point coordinates. 1, 2, 3 means 1i plus 2j plus 3k. That is written. Plus lambda of B bar is 3i plus 2j minus 2k. This is the vector equation of line. Okay, now find the equation of line is asked. Equation. We may write it as, this is vector equation of, suppose it is xi plus yj plus zk. It is 1 plus 3 lambda I na plus 2 plus 2 lambda j na plus 3 minus 2 lambda k na. Please observe me na. I 3 lambda I is there. To the 2 lambda j is there. 3k minus 2 lambda k is there. I am taking as common I j k. Now you equate I coefficient, j coefficient, k coefficient. So x is equal to 1 plus 3 lambda. Y is equal to 2 plus 2 lambda. Z is equal to 3 minus 2 lambda. Here x minus 1 by 3 lambda na. Here y minus 2 by 2 lambda na. 3 minus 3 by minus 2 lambda na. Observe me now. Some derivation. Directive form is there, of course. But if you do like this, the impression is good in the exams. So x minus 1 by 3 lambda. Y minus 2 by 2. Z minus 3 by minus 2 is lambda. All are equal to lambda. So the Cartesian equation is asked is, you see an x minus 1 by 3, it is y minus 2 by 2, it is z minus 3 by minus 2. Okay na? That is the Cartesian one. It is a Cartesian equation of the line. Whereas the vector equation of line. Very simple. X minus that coordinate 1 by this coefficient 3. Y minus y coordinate 2 by the coefficient 2. Z minus 3 by here minus 2 is there. That is the Cartesian one. Very simple. Okay now? Like that you have to solve. Yeah. Just pause.